Alright, so here are the directions for the flame test lab that we're going to be doing tomorrow. So the question, so you need to have out your lab sheet and fill in the blanks as we go along. So the question that we're asking is what colors are given off when particular elements are exposed to flame? So I'll repeat it. What colors are given off when particular elements are exposed to flame? What colors are given off when particular elements are exposed to flame? So here's the background research and fill in the blanks as you go. Generally, an electron, as we know, is going to be located in an area around the atom that requires the least amount of energy. Okay? We know electrons are lazy. They want to be where the least amount of energy is possible. When the electrons are like that, and when we write the electron configuration for it, we say that the atom is in its ground state electron configuration. So all the electron configuration that we have been writing have been in the ground state, where the electrons are in the least energy available. However, this ground state electron configuration can be disrupted if energy is added to the atom, and therefore, if the energy is added to the atom, it's also added to the electrons. When energy is supplied to an atom, the electrons are going to jump, yes, like jump, jump, jump to a different sublevel that requires more energy. In this case, we say that the atom is excited. It's excited because it has more energy. And don't you know, when you are excited, you have a lot of more energy. So, you add energy to an atom, to the electrons. The electrons jump from their ground state into a sublevel that requires more energy, and therefore they are excited. However, electrons, again, they're lazy. They don't like to be in this excited state for very long. So, after an extended period of time, they're going to release that energy in order to return back to the ground state. Because, again, they're lazy. They don't want to stay there. So, according to the law of conservation of energy, energy can be neither created nor destroyed. This means that the energy that the electrons lose, it can't just disappear, can't just magically go away. It has to be released in some sort of form. It has to go somewhere. So, in this lab, the electrons of a particular element are going to be excited through the energy it gains when you place those elements into a flame. Yay, fire! When the electrons release energy to return back to their ground state, they're going to release that energy in a form of a light wave. Okay? So it will look like different colors of light. Different waves of light have different energies, and therefore different colors are going to appear for the different elements. So this is how we're going to do the lab. You're going to light your Bunsen burner in a safe manner that you all know how to do now. Then you're going to have a collection of Q-tips. Take your Q-tip, you're going to have a beaker of water. Just put the Q-tip in the beaker, get one end of it wet, only one end. Once it's wet, you are going to have a weighing boat, and inside of it will have a compound that has a particular metal element in it. So here, this is my sodium, and it'll be labeled for you either with the name or with the element symbol. So I'm just going to put the wet end into my substance, and then the powder or the solid will stick to the Q-tip because it's wet. Take it, very easily put it into the flame, and see what color results. Now, here's the only thing you got to be very careful with this lab. Don't put it right at the base of the flame. We don't want the crystals of the solid to fall into the flame or get stuck on the edge of the Bunsen burner. If that happens, then every time you light the Bunsen burner, it's going to have that color, and you won't be able to tell the difference in colors between the different elements. If that happens, turn off your Bunsen burner, just get a piece of paper towel, wet it down, and try to clean it out as best as possible. Get it off of there. So you're putting the Q-tip in the flame, see what color it is. Don't hold it in so long that it catches fire. Okay, you're just seeing, you don't want the Q-tip wood to burn. Once you're done, put it into the beaker on your table that says trash. It will go out. It might even have some water in it just to extinguish the fire. No big deal. So you're going to do that for all of the different weighing boats at your station to see what colors they represent. And then I can't find it. You're going to have a piece of paper that has different Bunsen burners on it, and I want you to color in what color did you see, what color did you observe, and make sure you label what element it was for each color. When you're done, I'll have pictures up on the screen of places, of situations where this chemistry is applied in different situations. And so you're going to use the knowledge that you just gained and hypothesize what element is being used to create those colors. One situation is going to be road flares, one situation is going to be a street lamp, and one situation is going to be fireworks. So, should be a fun lab, a lot of cool colors, and I'll see you tomorrow.